Find the domain of the following functions in interval notation. So in part A we have function 3 over x plus 2. Okay, and we know a fraction is always defined as long as the bottom is not 0, because a number, any number divided by 0 is undefined. Okay, 3 is good, so this should not be, the domain should not make the bottom 0. So x plus 2 should not be 0. So let's find when x plus 2 becomes 0. Okay, clearly x equals negative 2, negative 2 plus 2 is 0. So negative 2 makes the bottom 0. So negative 2 should not be in the domain. Okay, so the domain is all real numbers except negative 2. So how do we write that? So all real numbers, negative infinity through positive infinity, but negative 2. So negative 2 is here, this should not be. So in interval notation, it will be negative infinity through negative 2 union negative 2 to infinity. Okay, we just removed negative 2 from the domain, from the set of real numbers. Okay, done. Part B, same thing, x square plus 9 over x square minus 9. The bottom should not be 0. So let's see for what values of x the bottom becomes 0. We have x square minus 9 equals 0 on the bottom. Solve for x, move 9 to the other side, x square equals 9. Take square root both sides. So using square root property, x equals plus minus 3. Square root of 9 is 3, plus minus is coming from the square root property. Okay, so x equals 3 or negative 3 make, okay, x equals 3 and negative 3 make the bottom 0. So they should not be in the domain. So we write in this way. Let's look at the number line, negative infinity through infinity. Negative 3 should not be there and 3 should not be there. So domain in interval notation, negative infinity through negative 3. Okay, negative 3 through 3 union all parentheses. Parentheses means negative 3 is not included. Union 3 through infinity. Okay, that's the domain. Let's go for C. Fx equals x square minus x plus 1. This is a polynomial. Bottom is 1. This is always defined. So this is a polynomial. And polynomials are defined everywhere in the number line. So domain is all real numbers. So negative infinity through positive infinity. There are no restrictions. D. Okay, so the bottom should not be 0. Okay, at the same time we got square root of 4 minus x squared, and we know square root is defined for non-negative numbers. So 4 minus x squared should be bigger than or equal to 0. Square root of 0 is fine. Square root of 0 is 0. That's all right. And 4 minus x squared should be bigger than or equal to 0. But since this square root is on the bottom, we should not have 0 because 2 over 0 is undefined. So in this case, 4 minus x squared should be positive. So we try in this way then. Let's do here. So 4 minus x squared should be strictly bigger than 0. It cannot be, just for the square root, it could be bigger than or equal to 0, but this is on the bottom. So 2 over 0 is not good. So we should not write bigger than equal to sign, not equal to sign. Let's solve for x. Negative x squared, so I want to move this to the other side. So add x squared both sides. So 4 bigger than x squared. Okay, let's write x squared in the left side. So x squared less than 4. Okay, x squared less than 4. Now x squared less than 4, any value of x, okay, that's less than 4. if we take square root both sides, okay, so both sides, we get absolute x, because square root of x square is square root of x square is absolute x, less than square root of 4 is 2. Absolute x less than 2 means on the number line all the x should be less than 2, so they are in between -2 and 2. Any number in between -2 and 2 has absolute value less than 2. So the domain is only the numbers in between -2 and 2. Okay, so -2 and 2. We can try. If we take -2 or 2 or -2, then this is 0. Square root of 0 is 0. 2 over 0 is undefined, not good. If we take something outside of 2 or less than -2, let's say 3. If we take 3, 4 minus 3 squared, 4 minus 9, that's -5, and square root of -5 is not a real number. Okay, so the domain is -2 to 2. And part E, domain, so we have a fraction, so bottom should not be 0. That means, look at here, x equals -5, -5 plus 5 is 0, so x should not be equal to 5. So if we draw number line just from the bottom, we know x should not be equal to -5, so -5 should be avoided here. And on the top, square root of 4 minus 2x, so this inside number, this should be always bigger than equal to 0. 0 is fine in this case because square root of 0 is 0, and we have 0 on the term, that's all right. In the previous question, we cannot have 0. Square root is defined for 0, but due to the location, it's on the bottom, so we just took bigger than 0. Now 4 minus 2x, we write bigger than equal to 0. Okay, let me erase a couple of things here. So 4 minus 2x bigger than equal to 0. Solve for x, -2x, move this to the other side, so add 2x both sides. So 4 bigger than equal to 2x. I'm going to write 2x in the left side, so 2x, this pointed part, less than equal to 4, divide by 2. So if we divide by 2, we get x less than equal to 2. Okay, so yeah, x less than equal to 2. So here is 0, 2. So we should have x less than equal to 2. So 2 is included, and all smaller numbers all the way to -infinity, but we shouldn't have -5 because -5 makes the bottom 0. So the domain is -infinity all the way to 2, but -5. So we have to write in this way: -infinity through -5 and -5 through 2. 2 is included, so bracket. Look, x less than equal to 2. Equal to means included, so bracket.